In this video, we will look at the SumtoProduct and ProducttoSum identities. We will be using the sum and difference identities that were derived in the respective lesson. They are listed again here for your convenience. If we add these two cosine formulas together, we'll get cosine of alpha minus beta plus cosine of alpha plus beta is equal to the cosine of alpha times cosine of beta plus sine of alpha times sine of beta plus the cosine of alpha times cosine of beta minus the sine of alpha times sine of beta. Now, after we simplify this, we'll be left with 2 times cosine of alpha cosine of beta. Solving for this, we find that cosine of alpha times cosine of beta is 1/2 the quantity cosine alpha minus beta plus cosine of alpha plus beta. This is the ProducttoSum identity for the cosine function. If instead we subtract the two cosine formulas, then we'll get 2 times sine of alpha times sine of beta, right? The only thing that changed from the previous slide is instead of this being a minus, this being a plus, it was a minus. Solving, we get sine of alpha times sine of beta is 1/2 times the quantity cosine alpha minus beta minus cosine of alpha plus beta. And this is the ProducttoSum identity for the sine function. Well, now we're going to do the exact same thing to the two sine formulas. First, we'll add them, and then we will subtract them. So adding sine of alpha minus beta plus sine of alpha plus beta, sine of alpha cosine of beta minus cosine of alpha sine of beta, plus sine of alpha cosine of beta, plus cosine of alpha sine of beta. And this gives you 2 sine of alpha cosine of beta. Solving, we get sine of alpha cosine of beta is 1/2 the quantity sine of alpha minus beta plus sine of alpha plus beta. Now if we subtract, again, the only thing that's going to be different is this plus sign is going to switch to minus. Now simplifying gives a negative 2 cosine of alpha sine of beta. And if we solve, cosine of alpha sine of beta is 1/2 sine of alpha plus beta minus sine of alpha minus beta. The previous two that we derived are both ProducttoSum identities for a sine-cosine combination. Because of the commutativity of multiplication, both are not necessary, right? They're the same. All you have to do is flip the order using commutativity of multiplication. What we're asked to do here is write the following as the sum or difference of sines and cosines. All right, so 2 cosine of 7 theta over 2 times cosine of 3 theta over 2. This becomes 2 times, now apply the cosine ProducttoSum, 1/2 times the quantity cosine 7 theta over 2 minus 3 theta over 2 plus the cosine 7 theta over 2 plus 3 theta over 2. This will be cosine of 2 theta plus cosine of 5 theta. We now look at sine of 4 theta times cosine of 2 theta. So 1/2, using one of the sine cosine ProducttoSum. Sine of 4 theta plus 2 theta plus sine 4 theta minus 2 theta. This winds up being sine of 6 theta over 2 plus the sine of 4 theta over 2. And finally, let's look at cosine of 3 theta times cosine of 5 theta. Again, this is a cosine product to sum, 1/2 cosine of 3 theta minus 5 theta plus the cosine of 3 theta plus 5 theta. This will give cosine of negative 2 theta over 2 plus the cosine of 8 theta over 2. And since cosine is even, this can be written as cosine of 2 theta over 2 plus the cosine of 8 theta over 2. Now we will look at the sum to product. To do this, let alpha be theta plus phi over 2, and let beta be theta minus phi over 2. Then alpha plus beta would be theta, and alpha minus beta would be phi. If we plug these in to the product to sum identities we just derived, we get the cosine of theta plus phi over 2 times the cosine of theta minus phi over 2 is 1/2 cosine of phi plus cosine of theta. And for sine, we get 1/2 cosine of phi minus cosine of theta. Sine of theta plus phi over 2 times cosine of theta minus phi over 2 is 1/2 sine of theta plus sine of phi. And then using the other one, we'll have 1/2 sine of theta minus sine of phi. If we simplify these to solve for the sum difference, sine of theta minus sine of phi is equal to 2 times sine of theta plus phi over 2 times cosine of theta minus phi over 2. My apologies, a typo in the slides. This should not be a minus. This one here should be a plus. Right, that was solving this one. Sine of theta minus sine of phi is 2 times sine of theta minus phi over 2 times the cosine of theta plus phi over 2. Cosine of theta plus cosine of phi is 2 times the cosine of theta plus phi over 2 times the cosine of theta minus phi over 2. And finally, the cosine of theta minus the cosine of phi is negative 2 times the sine of theta plus phi over 2 times the sine of theta minus phi all over 2. Here we are asked to find the exact value of cosine of 15 degrees minus the cosine of 75 degrees. If we look at this, cosine of 15 degrees minus, we're going to use the difference formula here. So this is a negative 2 sine 15 degrees plus 75 degrees all over 2 times the sine of 15 degrees minus 75 degrees all over 2, which is negative 2 sine of 45 degrees times the sine of negative 30 degrees. Right, sine is odd, so we could write this as 2 times the sine of 45 degrees times the sine of 30 degrees. This will be 2 times root 2 over 2 times, now sine of 30 is a half, and we wind up with root 2 over 2. Okay, we are now asked to verify this identity. Now let's start with the left-hand side. Using the difference formula in the numerator, -2 sine 4t plus 2t over 2 times the sine 4t minus 2t over 2 all over 2. Now if we use the sum of the sine identity, sine 4t plus 2t over 2 times cosine of 4t minus 2t over 2. Now what we see, they will drop out. The 2's will drop out. We're left with negative sine of 4t minus 2t over 2. So 4t minus 2t, 2t over 2. This is sine of t over cosine of t, and that is negative tangent of t. And finally, let's verify that the cosecant squared of theta minus 2 is cosine of 2 theta over sine squared of 2 theta. Let's this time start on the right-hand side. Cosine 2 theta over sine squared theta. Now, cosine of 2 theta is 1 minus 2 times sine squared theta. And we keep that sine squared of theta. Now, what we can do is write this as two separate fractions. 1 over sine squared of theta minus 2 sine squared theta over sine squared theta. Since 1 over sine is cosecant, this becomes cosecant squared theta minus sine squared over sine squared is 1, so we're left with 2. That concludes our video on the ProducttoSum and SumtoProduct identities. The next video is dealing with trigonometric equations, and it will also happen to be the final video in this lecture series.